everyone. Thank you for joining today's sessions on getting started with Grafana Loki, a modern logs database. My name is Alfredo. I'm a solution engineer at Grafana Labs. During these sessions, we will explore the powerful capabilities of Grafana Loki and how it can revolutionize the way we handle log data. Whether you are new to Loki or already familiar with it, I'm excited to take you on this journey of discovery and help you harness the true potential of this platform. Now, without further ado, let's begin our sessions. I want to start off by sharing about Grafana. Many have known Grafana as a visualization tool, unifying data sets across your organization into a first pane of glass, allowing DevOps, SRE teams to view holistic business applications and infrastructure health. Grafana has built on a plug-in architecture with hundreds of connectors to popular tools and allow users to interact in real time with underlying data source without creating data copies. And that has evolved. Grafana Labs, the company behind Grafana, has built the world's first open and composable observability stack. It is natively designed for monitoring hybrid cloud, container, and microservices environment. The Grafana stack includes multiple pillars, including preventing, finding, and acting. For today, I will focus on finding pillar specifically for logs where Grafana Loki is. I want to start with the design principle behind Grafana Loki. One challenge we often hear is the difficulty of operating at scale. Traditional logging metric systems tend to struggle as data volume grows, resulting in slow indexing and sluggish queries, especially in logging. Another issue is with the high cost and effort involved in scaling these systems. Factors such as the number of personnel required for deployment and maintenance, the hardware footprints, and licensing costs contribute to this pain. Additionally, vendor lock-in can be a concern as some solution relies on proprietary standards or lack full integrations after acquiring other vendors. These are the exact reasons why we built Loki. We wanted to give our users, customers, an easy-to-use, scalable, cost-effective logging platform that can correlate logs with metrics and traces. With this capability, Loki can address the following use cases easily. The first one was to provide DevOps an effective way to debug, troubleshoot their applications. This is one of the key use cases of Grafana Stack and also something that we will illustrate and build later on as part of these sessions. Besides, we also wanted SRE teams to have more control on alerting capabilities and manage powerful alerts based on collected log data. And last was to make sure that data engineers have the best tools on the market to extract useful insight from the log data. The main challenge for the Loki team was addressing these challenges in an efficient way, but in the meantime, building something that can run at scale and be operated in a cost-effective way. Loki's first key strength lies in its efficiency at scale. The concept behind Loki is simple. We index a small part of the information known as labels and store the log content in object storage such as S3 or Google Cloud Storage, for instance. This approach significantly reduces the log data footprint and improves performance at scale, all at a fraction of the cost. Correlations is another core feature of Loki. It enables seamless one-for-one correlations with metrics and traces, allowing developers to avoid the challenges of indexless logging and greatly improving their debugging workflow. Logs can then further be correlated with traces, and traces can be correlated with logs, providing valuable insights across multiple observability pillars. Loki also allows logs to be treated as metrics. This means developers can generate ad hoc metrics from logs, even from applications that do not emit metrics natively. This feature empowers developers and data engineers to derive metric-level insight from log data, enhancing their monitoring and analytics capability. Furthermore, Loki is format agnostic. It accepts logs in various formats such as JSON, regex, and many other supported log structures. This flexibility allows developers to store logs in a centralized locations without the need for complex modifications to the log data itself. Since its first release in 2019, Loki's popularity continues to climb. As of recent, it has collected close to 20,000 GitHub stars. It just shows how much love it has received from the community. Now let's dive deeper into some technical aspect of Loki, starting with ingest. Loki accepts logs in all formats, eliminating the need to make upfront decisions or enforce strict data consistency in the form of schema. It allows for parsing log at query time, ensuring adaptability to changing usage patterns. Log can be sent directly to the Loki API or conveniently processed using an agent. This flexibility provides ease of integrations and efficient log ingestions for diverse use cases. To set up a Loki, the basic configurations involves installing Promptail agent on each node. The agent is responsible for forwarding logs to Loki. Loki serves as a centralized log system capable of receiving logs from all your applications and services across different clusters. Once the logs are ingested into Loki, you can leverage Grafana to read and visualize the logs. If you prefer a command line interface, Loki also provides a CLI tools as well as a REST API, making it extensible and scriptable for various use cases. This flexibility empowers users to interact with Loki in a way that best suits their needs. Promptail is indeed the agent specifically built for Loki, and it shares service discovery features with Prometheus. The Grafana agents, on the other hand, incorporates Promptail while also being able to collect Prometheus metrics and traces, providing a unified agent for multiple purposes. Though Loki works seamlessly with Promptail, it is not limited to just using Promptail for log ingestions. There are other options available depending on your specific needs, things like using a Fluentd, Lambda, or many other things. These options provide flexibility in choosing the log ingestions method that align with your existing infrastructure and preference. Now, there are three main ways to run Loki, offering different options depending on your requirements. First is a single binary. This is a quick way to get started, suitable for testing environments. It involves running Loki as a single process on a single node. While it can handle significant loads, it is typically used for a very small setup. Next, we have microservices. These installation options allow for scaling each Loki microservices independently. This ensures consistent query performance even with large data volumes. It is recommended for larger installations and production workloads, but it offers complexity. Lastly, we have simple scalable deployment. This mode offers a straightforward deployment approach for running Loki. It is recommended mode from our team as well. It groups and generates read and write paths independently, allowing simpler scaling and monitoring tasks. Loki is available in several flavors. We have the open source software, the OSS, we have the enterprise, and also we have a SaaS, which is software as a service in the form of Grafana Cloud. For users looking for a hassle-free experience, Grafana Cloud free plan offers a compelling options, and this can be an excellent way to experiment with Loki and get started quickly. Now we understand the Loki architecture. Let's focus on Loki concepts itself. This is an example of Prometheus model. Now let's look at how Loki model looks like. Loki takes fundamentals of how Prometheus deals with active series and repurposes them explicitly for logs. In these examples, the metadata labels are applied to each log entry. Here we are applying label for applications being used, which in this case is Nginx, and the specific environment where the logs are coming from. This concept is the basis for the index, and this ensures that each set of log entries with the same labels are identified as a unique log stream. Logs line itself are not indexed. Instead, Loki put the log line into an object storage along with the index content, which is a pretty inexpensive method to store the data. This makes index very small because we only have the metadata in the index, and all the bigger stuff like the log line are sent off to the object storage. One important thing here, Loki is able to search across all the logs independently if what you are searching for is part of the index or not. In Loki, logs are organized into log streams. A log stream consists of a collection of log entries that share identical labels. This grouping allows for efficient querying and analysis of logs based on specific criteria. By leveraging log streams, users can easily navigate and extract insight from their log data. Most other log aggregations tools build indexes around the full text data, which is great for great optimizations if you plan on reading back most of the data. But logs are normally write once and read never, so why spend all the compute generating indexes for that data that you'll never read? The fundamental difference from other solutions is that Loki doesn't index the log content. It only indexes the metadata. This means it's much easier to scale out of the box. Having such a small index gives us some huge operational advantage. How efficient? Well, this is just an example. With 200 megabytes of index data, I can address and search up to 10 terabytes of the log data. If you are familiar with more traditional style logging solution, you'll notice that this Loki index size translation is super small compared to other solutions. Now let's get on the query capabilities. People who are not familiar with Loki think that because Loki doesn't index the log contents, its query capabilities are very poor. That is obviously not the case. There are two stages of the query. Log queries return a log result with log lines that match the given query. It consists of first the label matchers as part and filter the expressions part. The label matchers work essentially the same way as in Prometheus. In this case, we filter on a cluster and a job label, which identify the source of the logs. The second part is used to filter down the logs, which can be done with string matching and regular expression matching. I don't want to go too much into detail here, but you can also use parser and formatting stages to parse, for example, JSON or log formatted logs and rewrite them. Now let's look how this translates at search time. As an example here, let's say we have 1 petabyte of raw logs, which after labeling results in around 80 terabytes of labels. Let's also assume our time frame is 7 days in this case when we run the search, and that 7 days of data is around 1 terabyte of size. Our query end up processing up to 1 terabyte per second, which end up taking about probably 8 seconds in ideal settings. So querying with Loki itself is still fast. It's just a different approach than traditional logging system. Now let's look at the demo I have here. So here I have Grafana interface presented in my browsers. I'm specifically in the Explore page and I'm looking at my Loki Nginx logs that I've mentioned earlier. So I have Promptail collecting data from my Nginx access logs. Now, the first thing I can do here is, let's say I want to look at all the access logs. So I can start off by filtering specifically the file name and I want to look at the JSON access logs, for examples. So when I run the queries, here we can see that at the bottom part, I have all the raw logs line that Loki has ingested and it presents that to me. One thing I want to highlight here is currently I'm using the builder mode. So builder mode is designed to help users who are new with LogQL, the Loki query language, when they want to search their logs. If you're already familiar with LogQL, you can go to the code mode, and this is the kind of like place where you will be running your query automatically. But just for this demonstration purpose, I'll be using the builder mode. If you are wondering what is the code mode equivalent, it is available at the bottom part here as well. All right. Now, as I'm looking at the log at the bottom here, I can see that this is actually my raw log contents. As I expand that, I can see some of the fields. Now, these fields at this stage are pretty much all the labels that Loki recognizes. Now, what if I want to, let's say, look at my data and we can see that within my content here, there's quite a few of other fields. For example, like status, we also have other things like request URI. what I can do is to add a JSON parser. So JSON parser allows Loki to apply a parsing stage at the query time. And since all of my logs is in a JSON format, I can just use this pre-built parser available. There are a couple of other options here. So if I open this kickstart queries, I have also something called log formatter. Log formatter is applicable for those key value pair style of log. So you have the fields follow with the values on. We also offer some other parser, for example, regular expression and also pattern. I will recommend you to look at our documentations for more detail in these other options, right? So let me just run the query here, and let's look again at my same log line here. If I go to the fields, I actually have a lot more fields now because Loki has applied a JSON parser on top of my log contents at the query time. So now if I want to, for instance, I want to look at the status. So I want to see maybe everything that has a status 200. I can do that by just creating this to the value. So I can see that my log line now has these label filter expressions. You can also look at how that looks like in the code, and I can run the query. All right. So this is pretty much all my successful access in because this is a JSON, this is an access log of an Nginx. Now let's say that maybe I want to filter only for those field access. So I can do that by just using instead of matching one-to-one, I want to do a matching regular expressions. And here I can fill in my regular expressions to anything that has a code of 400 and above. So 400 or 500. So I'll just do that this way and I can run the query here. And I can see that this is all my log line that has a failure. So I see the status. So if I open the ad hoc statistics, so I can see that there's a lot of 500, a couple of 404, and a few on the 400 as well, right? So I can go a little bit deeper because as of recent, we have working to improve log explorations in Grafana. So if I'm interested to just see the status here, I can just click on that and it pretty much will change on my log line temporarily for just showing the status code, right? If I want to go back to the original log line, I can still do that by just showing this original log line, all right? Now, one thing I want to show you next is how are we able to use logql to generate the ad hoc metrics. So for example, here, let me just close this. Let's say that I want to understand more about how many of user accessing my applications broken down by the status code. So I can do that by just adding an operations. Let's see, first I do the count over time. And then I will follow that by sum. To sum that by the labels that we want. Of course, that is a status. We know that earlier, all right? So we can see that the code is here. So if you notice with regards to the ad hoc metrics, it is very similar, pretty much the same with Prometheus, right? The only difference is instead of tier is your metrics name, this is actually a log query that is used by Loki to kind of like search for the logs. So when I run the query, what will happen then is it will present me this graph because now all of these are now a matrix, right? Now I can see that for all the status 200, how are those? 301, 400, 404, and many others options as well there. I can go deeper if I want to say, hey, I still want to look at the log sample. At the bottom here, I can still open the log samples. There's also an option for me to open this in the split view if it's easier for me to look at the situation. So now it actually helped me to troubleshoot, for examples, there's about 500 here. If I filter just for this specific time, it will also show me specifically, all right, these are all the 500 that we have, right? Now, of course, once you build this, you can add this to a dashboard, create your own dashboard to explore all the contents related to your logs. For examples here, I have one dashboard that is coming from the same Loki Nginx access logs, but it's just been presented in a way to give you an idea what we can do with the logql itself. So we can see a couple of informations like the total request by status code, the bytes in, bytes out, and we can still see this request log line So this request log line has been formatted with the line format functions, which allows you to format the output of the logs line for easy read. So of course, there's a few other options here. This is a Grafana dashboard, so some of you might be already very familiar with some of the panels itself. It's just the underlying data that power these panels are actually coming from the log QL. All right. So I will end my demo here and I will switch back to my presentation slide. All right. So as an examples earlier, we look a lot on the example how we can search our data with Loki, how we can apply some parsing. We can search a specific fields or specific keywords if you want to. We can also generate ad hoc metrics out of our logs, right? Now, the example dashboard I showed earlier is available in our public Grafana that is in play.grafana.org. So if you're interested to look at that dashboard to kind of look a bit more in details, you can just go to play.grafana.org and look for Nginx Service Mesh Dashboard. Now, we think this is a good trade-off, thinking about how Loki design principles and address all these challenges. You can still capture logs without upfront decisions on their formats, keep smaller indexes that are cheaper to run, but still give reasonable speed. Most importantly, you can dynamically slice and dice your logs rather than pick how they will be used upfront. So this gives you a lot of flexibility. We think of Loki model of paying for the needle rather than the haystack itself. All right. Next, I'm very excited to have SK Telecom, the container platform development team, to share their journey with Loki and Grafana. So we'll see. The floor is all yours.
네, 안녕하세요. 그라파나 로키를 도입하는 과정을 소개해드리기로 한 임성일입니다. 저는 타코에서는 LMA라고 해서 일반적으로 하는 매트릭 그리고 로깅을 개발해서 지원을 하고 있는데요. 보시는 것처럼 2021년까지는 EFK라고 하는 키바나, 일렉서치, 플루언트빗 연결해서 만든 로깅을 사용했었고요. 그리고 매트릭은 프로메테우스류를 사용했고 그라파나를 통해서 사용자에게 모니터링을 제공했습니다. 그러다가 이제 일렉서치에서 라이센스 이슈가 발생을 했는데요. 아시는 분은 아시는 것처럼 AWS하고 좀 마찰이 있었고요. 서비스로서 일렉서치를 배포하는 데 문제가 좀 발생하도록 만드는 라이센스였습니다. 그래서 구체적으로 들어가 보면 7.11 버전까지는 우리가 자유롭게 배포하고 할 수 있었는데 그 이후부터는 제약사항들이 거쳤고요. 저희도 이제 타코 그리고 추후에 TKS라고 이름이 바뀌었는데 TKS를 제공하기 위해서는 결국은 일렉서치를 같이 배포해야 되는 상황이었기 때문에 이 부분을 좀 해칭해야 되는 이슈가 있었습니다. 그래서 기존에 넘어갔네요. 그래서 이제 그럼 어떤 걸 대안으로 가지고 올 것인가 봤을 때 이제 로키를 살펴보게 됐고요. 이걸 우리가 갖다 쓸 수 있는 거냐라는 걸 봤을 때 최소한의 성능이 보장돼야 됐기 때문에 성능 테스트를 좀 진행했습니다. 사용했던 툴은 K6를 가지고 사용을 했었고요. 일단 저희가 사용하는 용례를 봤을 때 CPU 인텐시브 잡보다는 대부분 메모리들을 많이 써서 데이터들을 정확하게 잘 적재하느냐 이 부분이 포인트였기 때문에 그런 관점에서 테스트를 진행을 했었고요. 이제 좀 말도 안 되는 상황이 과도한 부하를 했을 때는 인제스터 쪽에서 문제가 발생하는 그런 현상들이 있었습니다. 인제스터는 프로메테우스가 아니라 로키에서 데이터를 실제로 데이터에 적재해주는 역할을 하는 부분이고 모듈이고요. 근데 약간 메모리 릭이 있고 그게 해칭되는데 좀 오래 걸린다라는 느낌이 좀 있었습니다. 더 이상 파지는 않았었고요. 저희가 이제 받아들이기에는 옆에 보시는 것처럼 100노드에서 각 노드당 50개의 컨테이너가 있고 그리고 컨테이너들은 1초에 1K 정도의 로그를 만든다고 가정을 했을 때 지금 보시는 그래프처럼 인제스터의 로그가 메모리가 쭉 증가하다가 6.5기가 정도에서 멈추는 걸 확인했고요. 이 정도면 충분히 우리가 갖다 쓸 수 있겠다라는 판단을 했습니다. 그래서 이제 기존에 있던 이런 그 중앙 로깅을 하는 기능 자체가 이렇게 바뀐 거죠. 그래파나를 사용해서 쓰는 걸로. 그래서 이제 보시면 그 로키 진영에서도 로그를 수집하기 위해서 프롬테일이라는 에이전트를 제공하고 있거든요. 근데 당연히 그 같이 제공하는 거기 때문에 로키하고 프롬테일이 훨씬 더 궁합이 잘 맞을 거예요. 저희가 기존에 앞에 말씀드린 것처럼 이미 플런트빗을 사용하고 있었고 거기에는 다양한 기능들을 넣었습니다. 앞에 보시면은 오퍼레이터를 써가지고 설정을 이제 다이내믹하게 바꿀 수 있는 거라든지 혹은 그 갑작스럽게 이제 늘어나는 로그 용량들을 커버할 수 있기 위한 여러 가지 장치들을 넣었어요. 예를 들면 스로틀링 기능 같은 것들이 그런 거고요. 그리고 우리가 이제 쓰면서 필요한 정보들을 추가할 수 있는 기능들을 개발해서 넣었기 때문에 현재에도 이제 플런트빗을 버리지 않고 그대로 쓰고 있습니다. 그렇게 해서 이제 로키를 TKS에 적용을 하게 되었는데요. 이렇게 함으로써 이제 데이터 자체는 S3, 그러니까 로키의 백엔드로 S3에 잘 저장해주는 기능이 있어서 S3에 데이터를 저장하고 있고, 그리고 그 프라이빗 클라우드도 저희가 지원을 하고 있기 때문에 그런 용으로 해서 미니오를 이제 호환될 수 있도록 해서 데이터를 저장하고 있습니다. 매트리스 같은 경우에는 타노스를 이용해서 이제 다 통합 관리를 하고 있고요. 근데 이제 로그를 하려다 보니까 타노스처럼 그 멀티 클러스터 관리해야 되는 이슈가 있는데 로키에서는 그걸 지원하지 않는 그런 이슈들이 있었거든요. 프로메테우스 같은 경우에는 사이드카들이 각각 데이터를 붙지만 그걸 그 타노스를 통해서 읽으면은 결국은 이제 데이터들을 다 갈라가지고 가져오는 기능이 있는데 사실 로키에서도 그런 기능을 좀 기대도 했고 그리고 그거에 대한 니즈들도 좀 올라온 것들이 있었거든요. 근데 이제 저희가 이제 2022년 작년 초에 이제 이 작업들을 진행했는데 그때는 이런 것들이 없더라고요. 그래서 우리는 어떻게 해야 될까라고 생각을 했을 때 프라이머리 클러스터라고 저희가 이제 TKS는 멀티 클러스터 기반인데 많이 점프를 했네요. 멀티 클러스터 기반인데 얘를 관리하기 위해서 이제 사용자들이 여러 개의 클러스터를 갖고 있거든요. 그런 클러스터들이 있을 때 프라이머리라는 걸 하나 지정해 놓고 거기에서 모니터링 그 컴포넌트들을 모두 집어넣는 형태로 해서 운영을 하고 있어요. 그래서 이제 로키 자체를 프라이머리에만 띄워놓고 모든 플런트빗들이 프라이머리에 있는 로키에다가 데이터를 넣자 이렇게 결정을 해서 운영을 하고 있고요. 근데 이제 저희가 이제 지금 서비스를 개발한 거가 AWS 상에서 하다 보니까 AWS 특징이 VPC를 만들고 그 안에 자원들을 좀 배포하는 형태로 되어 있고요. 저희도 틀지는 않고 그런 형태를 유지하면서 클러스터를 배포하고 있고 그래서 VPC 간의 통신을 위해서 뭔가 장치가 필요했어요. 그걸 위해서는 저희가 로드 밸런스를 하나 띄워서 로키 앞에다가 두고 바라볼 수 있도록 이런 작업을 했습니다. 그래서 이렇게 했을 때 전환 효과들을 좀 생각을 해보면 당연히 라이센스 앞에 처음 이슈가 됐던 라이센스 이슈는 해소가 됐고요. 그리고 기존에 이제 ES를 써보신 분들은 아시겠지만 생각보다 그 자원을 많이 먹거든요. 컴포넌트도 제대로 설치하려면은 메모리들이 기본적으로 뭐 2기가 이렇게 해서는 많이 뻗는 걸 보실 거예요. 그래서 이제 한 20기가 정도의 메모리를 썼었는데 현재는 로키 쓰면서 8기가 이하 아까 보셨듯이 그 저희가 산정한 최고 메모리 사용률도 6.5기가 정도였기 때문에 8기가 이하로 세팅을 할 수 있고요. 그리고 디스크 할당에 대한 고민도 예전에 ES 같은 경우에는 디스크를 어느 정도 줄 건지 플래닝하고 이런 것들이 있었는데 S3를 붙이면서 뭐 이런 것도 해소가 됐고요. 근데 가장 중요한 건 저는 이렇게 좀 생각을 했어요. 기본적으로 예전에는 뭔가 트러블 슈팅을 하든 뭘 하기 위해서는 프로메테우스도 확인해야 되고 또 키바나도 가서 확인해야 되고 그래 로그 보고 그때 매트릭이 어떻게 됐나 이런 작업들을 했어야 되는데 로키를 도입함으로써 결국은 얘들을 하나로 해서 묶어서 볼 수 있게 되었거든요. 지금 시간이 10분이 넘어가고 있는데 최대한 잠깐 틀어볼게요. 제가 이제 이것들을 다 묶어가지고 만든 그래파나 대시보드고요. 보시면은 위에 있는 정보들은 전체 뭐 돌아가는 파드의 숫자 그리고 밑에는 컬렉트되고 있는 로그들 그리고 더 밑으로 내리면은 매트릭 정보들을 이용해서 여러 가지 그래프들을 그린 걸 보실 수 있을 거예요. 그래서 뭐 여러 가지 고르게 되면은 하나하나의 파드들의 현황을 볼 수 있게 되는 그런 거고요. 좀 내려가 보시면 밑에는 뭐 CPU나 메모리, 디스크들이 어떻게 쓰고 있는가를 실시간으로 보여주고, 그리고 더불어서 하나를 고르게 되고, 이 문제사항 있는 이 올라가는 부분을 선택을 하게 되면 여러 가지 매트릭을 한다는 거고, 선택을 하게 되면 결국 이제 요 시간 범위를 해가지고 로그 정보라든지 매트릭 정보라든지 이것들이 다 바뀌는 형태로 해서 운영을 할 수 있거든요. 그래서 사실 제가 봤을 때 가장 좋은 효과는 이거였다라고 말씀드리고 싶습니다. 넘어가질 않네요. 사실 마지막 장이었고요. 제가 드리고 싶은 말씀은 여기까지입니다. 감사합니다.